is 6-1. Okay, we're going to spend today and tomorrow talking about 6-1 and exponential functions. 6-1 is key features of exponential functions. So we are going to spend some time looking at the graph. Okay, we're going to spend some time looking at how to do the graphs. So basic XY charts, but then also these transformations we've been doing all year long. Okay, we're going to be talking about those. Okay, so you can always pull the old charts out for those. I don't think I really put in here anymore, but we're going to be looking at those pieces. So, okay guys, basic information here. Exponential functions. When we're talking about an exponential function, it's of the form y equals a times b to the x. This is an exponential function because x is where? It's in the exponent. Okay, that's what makes something an exponential function, is when x is in the exponent. A little bit of vocabulary there. A is the initial value. So that number that doesn't have the exponent with, it's out front, is the initial value. It's also the y-intercept. Okay. And b has a couple of different names, but one of the things we can call b is the rate of change. And this connects us to exponential growth and decay. You may have done a little bit of this in some of your science classes or previous math classes. But if your base, the number with the exponent, okay, so b, rate of change, I'm also going to call it the base. Okay, if that number is greater than 1, then the function represents exponential growth. The function will be going this way, is what you see here. It's growing. Okay, and it's growing exponentially because it's going, it starts going up slow, 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 and then it's going upwards very quickly. If b instead is a number between 0 and 1, so a decimal, a fraction, then the function represents exponential decay. And that's where this graph would be exactly backwards. It would be starting out way high, and it would be going down very quickly. Okay? Those words of domain and range are still coming back. Okay, domain. As you look at this graph here, okay, and I didn't get arrows on either end of it, but do realize there would be arrows on either end of it, okay, extending us indefinitely. But if you look at this graph, it's going infinitely left, yes, and as it's going infinitely up, it's going to continue going farther right, farther wider. So domain, every time we do this, all real numbers, okay? Just all real numbers. Asymptotes. Okay, we've talked about asymptotes a little bit. Asymptote is a line, could be horizontal or vertical, that your graph never crosses, never touches. Well, in this case, we have an asymptote that's y equals 0. Y equals 0 is also known as the x-axis. Okay, so my graph here, as it's going off to the left and getting lower, it's getting closer and closer to the x-axis. I know in this paper it looks like it touches, yes, but realize in reality, if you were on Desmos and tracing, it would go closer and closer, not touching. And then range, well, because my asymptote is right here at y equals 0, my graph never goes below y equals 0, then the range is everything above 0. And so you have that range of y greater than 0. Okay? So we will talk some about domain and range. They will change a little bit. Well, not domain, but range may change a little bit depending on where my graph is. But it's still the general idea. Okay. So that's all your basic information here. Let's look at a couple of these graphs and get an idea of a basic graph, and then we'll do some switching around. Well, I guess you see the basic graph here, right? Let's work on graphing one. So, as we look at this, and if I recall correctly from Savas, you have some where it is like a 5-part question where they want the graph, but then they also want you to answer all these questions. So, what are the key features of each function? Include domain, range, intercepts, asymptotes, and end behavior. So, I'm going to talk about all this with you, okay? But, let's get a graph. Y equals 2 to the x. Thoughts of what I should do? I'm giving you a hint here with a blank XY chart, right? What x values do we want to pick? I like 0, 1, 2. I have 5 boxes, which means I want a little bit more than that. And I'll give you the hint right here. There's my 0, 1, 2. So what else am I saying we need to try? We need some negatives. So -1 and -2. And this is one of those, I know occasionally you get away without negatives. You do know if you don't do negatives, you don't get a full picture of the graph. Okay, so let's do some math. We're going to jump right into negatives. Okay, 2 to the -2nd. Now, this is where we walk the fine line. Do you know how to do this by hand? And do you know how to do this on the calculator? I would encourage you to know how to do both. Okay, I'm discovering on this test that some of us didn't know how to do things like 4th roots on the calculator. Okay, that's something we should know how to do. Okay, so now 2 to the -2. What's that negative exponent tell us to do? Negative fraction, right? That negative exponent says move it to the denominator. And so this is 1 over 2 to the +2nd. Well, what is 1 over 2 to the +2nd? 1/4. So I'm going to write 1/4. And I want you to know how to do that with your, by hand. But if you do that on the calculator, what's your calculator telling you? 0.25. Is that equivalent? Is that okay? It is. Okay, I'm not against it. And again, I'm not saying I only want you to be able to do it on the calculator, but we need to know how to use the calculators also. And as far as I know, all calculators are back in play. Okay, so you can get back to your old calculator if I changed it up on you. Okay, so what about -1? 2 to the -1 means I'm doing what? 1 over 2 to the positive first. Take it across the fraction bar. 1 over 2 to the positive first is 1/2, or 0.5 if you prefer. Now, again, the calculator will tell me this next one, but I also want you to get it memorized. 2 to the 0. What is anything raised to the 0? What? No? 1. Anything raised to 0 is 1. The calculator will back me up on that. Okay? So 2 to the 0 is 1. What about 1? What's 2 to the first? 2. And 2 to the second? 4. Okay. Let's graph them. Now, -2 1/4. What's that saying we're going to do? Left 2 and up 1/4 of a box. Good luck, right? -1 1/2 is left 1 and up 1/2 a box. Technically, it should be a teensy bit higher than the previous stuff. I don't know that mine always look that way, but okay. 0 1. Left, right, 0, up 1. 1 2. Right 1 up 2. 2 4. Right 2 up 4. Do those points look like they could form a graph similar to what we looked at up above? Okay. So as you draw this, the big key I will be looking for. As your graph goes off to the left, what are you not doing? You're not going to cross the x-axis, right? Now, I get it. Might your graph run into the x-axis and look like it's touching it? Yeah, I won't complain there. But if your graph clearly crosses the x-axis and you don't make any effort to fix it, I will complain about that. Okay? Because that makes me think you don't know that you shouldn't be crossing it. Okay, let's talk about some of these key features. Okay, domain. Okay, goes infinitely left, infinitely right. I have all real numbers written down. Negative infinity and positive infinity is also correct, yes. Okay, so however you want to put it in your notes, as long as you realize they are the same. My guess is, since I have all real numbers, that domain is one of the things in Savas they'll have all real numbers. So. Okay, range. How low is this graph going? 0, yes? It does not go below this x-axis, which carries a y value of 0. How high does it go? Infinity, right? Now, we can talk 0 to infinity, and I don't have it in my notes that way. So again, I'm going with probably what the book in Savas did at this point. And so they probably use the form of y greater than 0. Now, I have fancy notation in my notes. And again, if I did this, this means I saw it in the book or Savas. So fancy notation is a brace, y, a straight bar, y greater than 0, and a brace. Okay? Now, am I saying you have to write that for me? No, I'm not saying you have to write that for me. Okay? If you write y greater than 0, perfectly fine. But I just want you to be familiar that that's all this is saying. Okay? It's y such that y is greater than 0. Okay? That's, as I said, the fancy notation. You don't have to stress about it. Yes, the idea of 0 to infinity, whoops, is still correct as long as you don't put a bracket because it's not touching 0. Just like up here. Yes, negative infinity to positive infinity is still correct. Okay? However, you know, Savas on these is multiple choice. I'm going with they probably didn't give it in this form. Okay? And you can come back and tell me if I'm totally wrong later. Okay, what else do we need? Intercepts. Okay, so first of all, what do I mean by the idea of intercepts? Okay, so intercepts are where my graph crosses an axis. We can have x-intercepts. We can have y-intercepts. Do I have any intercepts here?
Yeah.
Yeah, what do I have?
Y.
We have a y-intercept. And where do we cross the y-axis?
0, 1.
Okay. Now, my y-intercept, I just have written as 1 in my notes. However, I very much agree what is as an ordered pair? Left to right 0, up 1. Okay? You could also say y equals 1. I just have it as the number. As long as you tell me that that's the intercept you're talking about, and that's a y-intercept, we're good there. Okay? Oh, and on this one, did we cross the x-axis? We did not. Okay. Any asymptotes?
Yeah.
Yeah? So remember, asymptotes are those invisible lines, horizontal or vertical, that we never cross, never touch. What's the invisible line that we're never crossing, never touching?
Yeah.
Okay, it's the x-axis. What do we call the x-axis?
Y equals 0.
That's y equals 0, isn't it? So there's an asymptote at y equals 0. And again, I'm not disagreeing with x-axis, but I can guarantee Savas is going to look for y equals 0. I don't think they're going to use axis there. And then the other one.
Exponential growth.
It's a little bit more than that. Okay. When they're asking about in behavior, it's based on what is my graph doing on either end. So anytime we talk about in behavior, we're going to look at, okay, what is my graph doing as it's headed left, as it's headed towards Mr. Stanley's room? And then what is my graph doing as it's headed right? So as it's heading to Miss Minnick's room. Okay, that's what we're talking about in behavior. So when I write in behavior, what we're examining is what is my graph doing as x approaches negative infinity, and what is my graph doing as x approaches positive infinity. Now it is based on whether your graph is growth or decay. That will affect my answers. So what we're answering here is what is y doing. So let's go left first. Okay? As x approaches negative infinity. So as my x values go left. Where is this graph going in terms of y values? In other words, what y value is it getting closer and closer to? It's getting closer and closer to this asymptote, and the asymptote value is 0, yes? So as x approaches negative infinity, as my graph is going left here, it's getting closer and closer to that y equals 0 line. So we're going to say y approaches 0 on the left. So when it's approaching an asymptote, it's approaching that number. It's approaching 0. Now think the other way. As x approaches positive infinity. So this is saying as we go right on my graph. The farther right we go on my graph, what y value is my graph approaching? It's going up to positive infinity, yes? So here, as x approaches positive infinity, y approaches positive infinity. Okay? Now, I used y in my notes. You could see the y written instead as f of x. Just beware there. F of x is another name for y. I prefer that they use y here, but you don't always get that. Okay, have I answered all questions? Okay, we've addressed everything they asked us to address. Questions I can answer for you. Okay. Well, shall we try another one, though? You gotta get a little fancier with this one, though, don't we? Okay. Y equals 5 times 1/2 to the x. And our first job is to graph it. We can't really answer some of this question until we graph it. Okay? You might want a calculator at your desk for some of this. You know, up to you. Or we can do this by hand. So our first one we have, okay, wait. What x values are we using? Okay, -2, -1, 0, 1, and 2. Okay, those are always my basic go-to x values for exponential graphs. Okay, if I do 5 times 1/2 to the -2nd. Not sure how much we've talked about this one. 5 times 1/2 to the -2nd. What's a negative exponent usually do? Goes to a fraction, yes? So it takes whatever is just there and moves it to the denominator. Technically, I don't know that we've used this phrasing, but it takes the reciprocal of it is what it's really doing. We have a negative exponent on a fraction that's already there. Thoughts on what we're going to do instead? If I mention the word reciprocal, what's the reciprocal of 1/2? 2/1. So that negative exponent, I know we just talked about, okay, it takes something to the bottom. Well, if it's already in fraction form, it's going to flip it. So basically that 2 is going to go to the top. So this is 5 times 2/1, if you will, to the +2nd. Well, what is 2/1 the same as? 2. So what math do we have to do here? Okay, 5 times 4 because 2 squared is 4. So this is 5 times 4, which is 20. Should we talk about the calculators a little bit? Do we know how to use the exponent buttons on our calculator? Okay. If you wanted to, could you just type that into the calculator? You can. 5 times. Now, 1/2. Do you have to do 1/2 as a fraction? You don't have to. If you want to, it's 5 times, do parentheses. 1 divided by 2. Exponent. My exponent button is my arrow. And what was I doing? I raised it to the second. Experiment with your calculators. Make sure you know how to use them. Whoops. Thank you. So that was supposed to be negative second. There we go. So I got us another answer for later on if you were paying attention. Okay, so you should be able to figure out how to plug that in and get a 20 out of it. And if you're trying to figure out, if you're not getting that 20, you're trying to figure out where you're going wrong, please ask. Because I know calculators have a lot of, funky little things you sometimes have to know. I am more than willing to help. Okay? So, could you plug in -1 that way? You can, which, I don't know if you guys saw what I did, but you can also arrow up. So if I arrow up, I can just go over here what I already typed, and just arrow over and change it. And so now I have it to -1. So what's my next answer? 10. Now, again, can we do that by hand? You can. 5 times 1/2 to the negative first. Well, the negative says to flip it upside down, yes? So it's 5 times 2/1 to the first. 2/1 is 2. 2 to the first is still 2. And 5 times 2 is 10. Okay. Now, what about this 0? Five times 1/2 to the 0. Anything raised to 0 is 1. Now, what's being raised to the 0? The 1/2. So this really just becomes what? 5 times 1, which is 5. Getting it? And again, find your happy medium. Are you a calculator person? Are you a by hand person? Or are you a little bit of both? I'd like you to be able to do both. If I had it my way, everyone would be able to do both great. What about 5 times 1/2 to the first? 5 times 1/2. So 5 times 1/2, you could say, what are your answer options? 5 halves. But how are we going to graph 5 halves? Or it is 2.5. Okay. I am perfectly fine with 5 halves for the record. I like 5 halves. It's just you then have to know how to graph it. And I accidentally plugged 2 in earlier. Did you guys catch the answer? Okay. It was 1.25. Or it's 5 times 1/2 squared. Folks, we've got to know how to multiply fractions. 1/2 times 1/2. 1 times 1 over 2 times 2, which is 1/4. 5 times 1/4 is 5/4, or 1.25. Okay, don't be afraid to grab those calculators and practice as we go through this stuff. Okay. Get it graphed. Now, -220. Where's -220? Left 2 and, I don't know, halfway up the graph above it. Okay, so my usual rule of thumb is know where it is, but you don't necessarily have to graph it. Okay, -110. Left 1 up 10. 0, 5. So left, right, 0, up 5. 1, 2.5, right 1. Up 2.5. 2, 1 1/4. So right 2, up 1 1/4 boxes. Yeah, as I said, about halfway up that, I'm guesstimating up there somewhere, but okay, get it graphed. Realize it's going up very steep, isn't it? Okay, it's going up very steep, or steeper than my last one was. Okay, same 5 questions as earlier. Some of these questions are going to have the same answer. Domain.
Negative, infinity, positive.
Okay. All real numbers, negative infinity, positive infinity. When it comes to writing it down for me on a quiz or a test, I'm happy with either. I'm happy you know what you're doing. I'm happy. I'll take either. Okay? I forgot to check something and talk about something on the graph, so we'll do it after this piece. Range. How low do my y's go? Is it 0 again? Okay. When you drew your graph, did you make sure that it does not cross the x-axis again? Okay. Until we start having a plus or minus number that moves my graph up or down, it's going to be that x-axis. Okay. So notice it's not running quite as close as last time because I was a little higher up, but it's still the same thing. So if it goes as low as 0, what's my range? Okay, 0 to infinity, or y greater than 0. Which, if I use the fancy braces, that's just fancy. It's set notation is what it is. Okay? And again, I'm not as much concerned that you can write it as much as you can recognize it. Okay? For instance, you see something like that on the SAT. I want that to be recognizable and you not be like, whoa, what is this weird language? I want you to be like, oh, that's basically just fancy speak for y greater than 0. Okay? So, but I think officially it's y is a real number such that y is greater than 0, something like that. Okay, what else do we have to talk about? Intercepts. Do we have any intercepts?
Yes.
Yeah, what do we cross and where? Okay, we cross the y-axis at 5. So we have a y-intercept at 5. And I did specifically say it is a y-intercept. So if you just put 5, that's fine. It is the ordered pair 0, 5, which it wouldn't surprise me if you have to put an ordered pair in homework. Surprising me that I don't have an ordered pair, though. Asymptotes. Any asymptotes? Okay. Y equals 0. Still that x-axis. Still not going below that x-axis. So y equals 0. And end behavior. Okay. Within behavior, there's always going to be 2 sets, the left set and the right set, and we're always going to start off the same way. It's always going to be what is x doing as the graph approaches. No. As x approaches negative infinity, what is my graph doing? So what is y doing? And it's going to be as x goes to the right. As x approaches positive infinity, what is my graph doing? We're always asking those 2 questions. So as x gets smaller, as x gets bigger. Now, as x goes left, as x approaches negative infinity, so as my graph goes left, what's happening? going up, 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 and away, right? So y is actually approaching positive infinity. Okay. What about as x approaches positive infinity? So as my graph goes right, where is it going? It is getting closer and closer to this asymptote, and so it's getting closer and closer to 0. So y is approaching 0. Okay? And if you want, you know, as x approaches negative infinity, realize this is asking as the graph goes left. As x approaches positive infinity is asking as the graph goes, not up, as the graph goes right. So x approaching negative infinity is as we go left. X approaching positive infinity is as we go right. Y approaching positive infinity is the graph is going up. That's fancy speak for up. Now, y approaching 0, that's we're running along the asymptote. Okay, so that is your asymptote there. Okay, so those are some little clues if you're someone that when you look back at this later, you want to know what those all mean. That's a little bit of what they mean. Okay, questions at this point? Let's talk about our graphs down here a little bit at the bottom. We're not going to necessarily get all the way through this first one, but we can at least start talking about it a little bit. Okay. It's asking us to graph again. I know, been there, done that. And then describe the graph in terms of transformations of the parent function. Now, parent function. That is our base function here. Okay. Our base function today is our exponential function. So when we talk about parent function, we're talking about, okay, what is the graph doing based on that b to the x, okay? So as you look at A, okay, as you look at A, thoughts, g of x equals 3 to the x plus 2 minus 5. We had this chart, this is back from topic 1, so this is back from like August. But we had this chart on like every page, formula page we used first semester, right? So, and there's more over there if you need them, but what do we know? What is each number telling this graph to do? Okay. Where are we going to shift? I heard some things, but I'm not sure what I heard. Okay, how about down 5? A number added or subtracted away from the x is up or down direction of the sign, yes? So this minus 5 is going to be a down 5. Okay? So that's one of the things that we need to know. That's the f of x plus c or f of x minus c. At least on this paper, that's how it was. What else do we know? What's the plus 2 telling us to do? To go left? It's with the x. And I keep saying this, anytime it's a number added or subtracted directly to the x, left or right opposite the sign. So then we're going to be going, since it's plus 2, we're going to go left 2. Now, for those of you out sitting out there saying, whoa, what about that 3? That 3 is my base, okay? That is my basic graph we're talking about here, okay? All this stuff that's being done is going to be done to y equals 3 to the x. Up above, we graph 2 to the x, 1/2 to the x. Now we're going to do 3 to the x, okay? So, what we will set up is, and I can teach this a couple of different ways. And it's kind of amusing. Could you plug each of these just values into each of these? You can to an extent. But when we shift left to right, we run into a problem there. So what I'm going to have us do is we're going to graph just 3 to the x with our -2, -1, 0, 1, and 2. And then after we graph that, we're going to do these other pieces of left 2 and down 5. Okay? So tomorrow, that is where we'll pick up. Okay? Is getting that graph done. I may have you guys start that tomorrow while announcements are on and whatnot. Savas is out there and available. You can peek in it when you're ready.